What I'd like to do is to take you through the classical approach to pumps operating in parallel. So to start with, we need to understand what operating pumps in parallel actually means. It means two or more pumps discharging into a common delivery line. And in that situation, the operation of the two pumps can be constructed by adding the flow of each pump at the same head to achieve a combined flow. So if we look at that in terms of a performance curve, here we've got our two pumps and they discharge into a common delivery line. The first pump curve is shown by that line. So that's the single pump curve. The two pump curve is the two pumps operating, you get double the flow at the same head. So at any head condition, you double the flow. The effect of that on the system depends on the system resistance. And here is a system curve that shows the system resistance of a relatively large pipe diameter. And you can see that the two operating points are here for a single pump and here for the two pump combination. But you can see straight away that by bringing on the second pump, you do not double the delivery at the same head. You only get a proportional increase because the system is throttling the pump performance. So if we actually have smaller pipelines, we will get a much higher system resistance. So the volume increase that we get by switching on the second pump is significantly lower. So you have, when you're pumping these increased volumes, you want the minimum system resistance that you can, in other words, larger pipe work. So if we look at the situation here, the volume increase for switching on the second pump is relatively small. The volume increase with the lower pipe resistance is relatively large. And these are the things that you have to mix and match to make sure that you get the benefit of the parallel pumping situation. Let's see how we construct that curve. So here is the pump curve, and we're going to look at the maximum diameter. This is the single pump operation. It's got a best efficiency point of just over 20 litres a second. What we're going to do now is to double the flow at uniform heads. So our starting point is zero flow. So a zero flow, the pump should be producing equal head with each pump. If we go to a point just here and double the flow, we will get to a point here. If we go to a point here and double the flow, we'll get to a point there. If we go to a point there and we double the flow, we'll get a combined pump curve that looks like this. So it's a very simple construction method. Some computer programs will actually allow you to draw that parallel curve. Others may not, so you might have to do it by hand. Let's go and see what operating points were like for a given system. Now, this is the classic situation where you've got a system that's in 150 millimetre Schedule 40 pipe, and it's 950 metres long with a static head of 68 metres. So this is just a single example to show you where the operating points will be. And the first thing we do is to actually calculate the system resistance for the system that we've been given. So we look at flow rates from 10 to 50 litres a second. We can go to tables and we can get the friction loss in 150 millimetre pipe at various flow rates, and these are given here. We can evaluate the total losses due to friction through 950 metres of pipe. And then we can add in the 68 metres static, which gives us a system resistance curve by the information in the far column. If we then construct that system resistance curve, that's basically taking those numbers and putting them in a graphical format. We can see that the single pump operation intersects the single pump curve at a point here, and that gives us a flow rate of about 24 litres a second at a head of about 77 metres. That's the single operating point. If we now go to the next point, which is the two pumps in parallel, we've only got an increase in flow to 38.5 litres a second, whereas people might reasonably be expecting it to be 48. It isn't 48 because the increase in resistance of the pipework, because of the increased flow, is actually self-throttling. So we get a situation where the two pumps duty is 38.5 litres a second, but at 91 metres. And that's the effect of the self-throttling condition when you put two pumps in parallel. If you will have three pumps in parallel, then you would basically push the curve one unit further to the right, and you can see what the effect of that particular pipe system would be on three pumps. And you will see again that you don't increase by anywhere near as much in terms of volume.